Yeah, can you hear me? Okay, cool. All right, cool. Hey guys, hello everyone. So thanks for joining this session on the Containerizing Couchbase with Kubernetes and Kubernetes for Microservice architecture. So I'm Anil Kumar, Cloud Container Kubernetes Product Manager for Couchbase, and also I'm responsible for our flagship product, Couchbase Server. In general, so I work on the high availability as a scenario, cluster management, tools, platforms. These are the areas I'm product manager for. All right, so the agenda for today, it's coming up. All right, okay, sorry. So the agenda for this presentation, right? So in this presentation, we'll start with a quick, a short introduction to the microservices. And then we move on to the practical side of it. We'll look at how the containers are powering microservices using the orchestration technology. One of the framework is Kubernetes. We'll take a look at the Kubernetes. And also how and why Couchbase is a good fit for, or a best fit for microservice architecture. Sorry, microservice architecture as well as for the containers, right? If the time permits, we will also have we'll do a quick demo. My co-presenter, Mike, so we'll do a quick demo of Couchbase running on the Kubernetes. By the way, he's there. All right. So what is microservice architecture, right? Again, as I said, I'll do a just quick introduction to the microservices, and I'll just move on to the container and other stuff, right? So as the name implies, the microservice architecture. Right? So I put a kind of a diagram which shows you. On one side, we have a microservice approach, and then there's a traditional approach, which is more of a monolithic applications. So as the microservice, the name stands for, right? So the microservice approach segregates the functionality into separate services itself, right? So it's like, you instead of building a monolithic application, you're breaking this application into smaller services with the clear business boundaries, right? So each microservice implements a specific end-to-end domain and business logic, business capabilities within the same service, right? And also that gives you a lot of, basically it gives you independent, you can independently scale these services because you don't have to scale the entire application. So let's say if in the traditional approach, you have everything in single monolithic application, you want to scale it, you have to scale everything together, right? Whereas in case of microservices, you can scale each services independently without affecting others. And also this gives you a chance for continuous integration and continuous development, right? So you can make a lot of changes, push those changes to each services, and it basically gives you a faster development thing, right? So again, now let's look at the why. So we know what's microservices. Why microservices? Because it gives you, in single words, agility, right? So the microservices enables you to, sorry, one second. So basically the microservice enables you to, enables a superior maintainability in large, complex and highly scalable systems. So the idea is like, you have a fine-grained microservice applications which enables a continuous integrations and continuous development. You can scale them independently, right? It gives you a lot of control. So whereas when you have the traditional approach of single monolithic application, your whole development is kind of bound because you have to do a lot of rigorous testing, the whole application. When you want to push an update, the update has to be retested, reconfigured, recompiled across the whole application and then deployed, right? So that's like the huge, the time to market will be hindered by that approach, right? And this is where the chance to microservices came into picture. Like microservices kind of, in last 2 years, it has picked up because the organizations started thinking about time to market is most important factor for them, right? So time to market, how do we get to the time to market is like, you cannot be building a monolithic application. So you have to start thinking about like microservice architecture where you have individual services, you can push a lot of changes in these services, you can test them, and also you can independently scale them, right? Now, how is it relates to the database, right? So let's take a look at the data sovereignty for per microservices. In the traditional approach, you will see a monolithic application. So you have basically a web application or a monolithic application which is talking to a centralized database, right? So you have a centralized database, a single monolithic database, and which is database for all your application, right? in that approach, and again, in this case, the database used to be the relational RDBMS, right? So now, with the microservices approach, what has changed is now you're breaking this services application into smaller services. You want your data to be closer to the services, right? So you want your data to be, for example, each service will have its own domain data, so that it can control the service. So let's say if I want to make a change to this service, that service is dependent on the data which you have, right? So you want your database to be closer to your service and also independent of the other services, right? And this is where the NoSQL fits really well into the microservice architecture, right? So as you can see, so we have stateful services which will be working very closely with the stateless services in the microservice architecture. Any questions before? Again, stop me in between if you have any questions, and I am happy to answer any questions. Yeah, go ahead.
So in this case, how do you handle the share the data between servers?
Yeah, good question. So one approach, and again, this recently came to, I was talking to one of our customer. One of the things which we kind of talked about is like, if with this architecture, you'll be having a separate database for each services, right? So the idea is like, again, we have a centralized database, right? One of the things which we discussed about, there's a new database type we released in 5.0, which is called ephemeral bucket. The idea with the ephemeral bucket is, it is exactly similar to the Couchbase bucket. It has the HA, you can do query, you can do replication, you get all the qualities of the database for this ephemeral bucket, but it doesn't have the persistence. The idea is like you can use this ephemeral bucket closer to your microservices. You can scale them linearly because we are single node, and I'll talk about a little bit more there. But for the system of record, you can push the data from this ephemeral bucket using the XDCR to the centralized database, right? So you can have a system of engagement, which is what we were talking this morning about engagement database. There's a database which is much closer to your microservices, but then you can have a centralized database, which is your system of record for consistency purposes, right? So you can use that kind of approach. All right, so, all right, any other questions? Again, the one approach, which as I said, mentioned, in the traditional approach, again, the database used to be the RDBMS, that was a choice, but now with the microservices, NoSQL is a kind of a good fit for it because of the nature of it, and I'll talk a little bit about why Couchbase is a good fit for microservices. So I talked about microservices, and I talked about, microservices was not a new, so there was a SOA in the past, but microservices kind of gaining momentum because of the technologies which are available now, right? And this is what I'm going to talk about the containers here, right? So containers, as most of you guys know, it's a lightweight, secure, standalone executable package. So the idea with the containers is again, we have a side-by-side comparison between the containers and a VM. So you have containers, which is, again, till the infrastructure and host, both are the same, like the host OS. So in the container way, so you basically don't have guest OS with the containers, right? So you use the same libraries of the host machine itself for the operating system action. So plus, there are different types of the containers where you can use the same app can be between the two containers, or you can have a separate app and libraries in each container. And again, the main reason, why containers are powering microservices is the isolation, right? So the container technology fits really well into the microservice architecture. The idea is like what microservice really needs is a isolation. Each services can be independently scaled. They can have their own application running. So the whole container fits into that in the area, which is like microservices will be a single process. So the containers are nothing but a single process, right? So the services running within the containers safely, we can run different microservice container with the same isolation in the containers. So you get the isolation, and then you get the scalability because you can scale the containers independently without affecting your other containers. Plus, if you want to push your next version, if you want to make a change, you can make the change to the containers, and let's say if something goes wrong, you can roll back, right? So without affecting your application. DevOps and containers love it because it gets into the low impact and risk update one container at a time. So the whole continuous integration and continuous development becomes much easier. Again, along with the other stuff, with the microservices, the container has its own benefits, which is you build once and you can run anywhere. Again, not new to you guys, but it's the idea is you create a single image, which is the same image which a developer is using it, a test is using it, a support is using it, and even the same image gets deployed in production. So there is no chance of misconfiguration, right? So the idea is you build it, whatever you build it is the same thing which is running on the production, right? High availability, so containers are by nature are lightweight, so they are bound to die, but that's where the next thing, which is like orchestration technology, which is needed to orchestrate these containers. But there is because they're lightweight, you can have redundancy for these containers. In case of stateful containers, it's much easier because, stateless containers, it's much easier because you can spin up multiple containers instantaneously and increase your capacity. But in case of stateful containers, and this is where like it gets a little bit of trickier, and I'll talk a little bit about the stateful containers. But in case of stateless, you can spin up more containers instantaneously, right? So you can have redundancy for your application. Performance is not impacted because it's not running in a guest OS or anything, so it's really lightweight, so performance is not at all impacted. So now let's look at the container orchestration. So I put together a slide to talk about what are the problems and what's the solution, right? So the problems are, like, as I said, containers are by nature very lightweight, and again, they're not full-fledged. They don't have a full-fledged operating system. They're not like a VM. So if they fail, they cannot restart themselves. So they die, and then you have to start the container somewhere else, right? So there's by nature, the containers are really lightweight. They makes them super flexible and fast. However, they are designed to be short-lived and fragile, right? So they need a orchestration. They need some orchestration which can schedule them. It can bring them back to the life, right? So again, as I said, like they die, and we need an orchestration to bring it back. And what's the job of orchestration? It is like the job is to orchestrate scheduling, monitoring these containers, and making sure that when the container dies, bringing back them to the life is the job of the orchestration. Along with that, the manage more of like a managed service, which is like continuous monitoring it, and if making sure that there's a recovery for these containers, right? So there are different frameworks for the orchestration technologies. There is Kubernetes, there is Mesos. The Kubernetes, as you guys might know, is becoming a de facto standard in the orchestration now. So we have been hearing about Kubernetes a lot. So let me talk a little bit about what is Kubernetes and where it comes from. Again, the Greek word for Kubernetes is helmsman, a person who steers a ship or a boat. So it's more of like a orchestrator guy or a coordinator kind of thing. So it was inspired from an internal project from Google called Borg. Again, they open sourced it. They built this Kubernetes project and they open sourced it, and now it is managed by the Linux Foundation itself. So it provides a declarative primitives for the desired state, like self-healing, auto-starting, scheduling across the host and replicating, etc. Right? So the current version of Kubernetes is 1.8. Again, the Kubernetes community itself is evolving. They're adding more and more functionalities to the Kubernetes. One of the things which has, again, it became really, really good fit for applications because they are stateless. In case of the stateful, like in case of database, there was kind of a challenge, which is like we didn't have a good solution for running a database, which is like a stateful container stateful, like basically a database in the container itself. And plus the orchestration didn't have any solution for that. And my next slide will talk about the challenges there. But the idea is like, so Kubernetes is, again, it orchestrates, it can basically bring the container back to the life. The problem with the stateful containers is like when stateful containers it needs a particular, some characteristics. Let me jump to the slide, 1 second. So let me talk about it. So there are certain characteristics of a database which you cannot run the database on the containers, because when you lose a container, even though we have redundancy for let's say if you create a Couchbase cluster and you set a replica of one and say, I want to have one copy of my data in the same cluster. So let's say if you lose a container, you can still fail over the container to the another replica node and bring back get the data back. But there's a time lag, right? Because you have to fail over, and then Now your application has to like wait for the time lag and then go to the next the replica node to start doing the read and writes, right? So this was kind of a challenging because like when the failover, yes, the solution is like we can failover, but there's again the nature of containers itself are like they're lightweight and there a lot of containers can die at the same time. So you should not be we shouldn't be relying on failover to happen for the data availability, right? So there was a beginning of this year when so Kubernetes has been contributing to the, as I said, like they've been mainly focused on the stateless. But in the beginning of this year, they created a stateful container. Previously, it used to be called as pet sets. Now they call them as stateful sets. So the stateful sets are still in a beta right now. So they are still not GA. So it's in beta. So it's a pretty good solution for the running a database on the containers. So stateful sets have some pretty good characteristics for database. So they have a persistent value they attach to. So let's say if I'm running my Couchbase on a Kubernetes cluster, and if I lose my pod in the Kubernetes terminology, when I lose a pod, it will reattach to the same persistent volume I was talking to before, right? Plus, it will maintain the same IP address and the IP address. So it's all these are the requirements for running a database in a containers as well as in the container orchestration, basically. Right? So now let me go into the Couchbase, containerizing Couchbase. Just one thing which I was going to talk about is like, so we have been focused on containers. So we started working on the containers. I think beginning in 2015. We took from the product. We strategized and said we have to support containers for database. Although it was new, and we knew customers are not going to be like going to deploy Couchbase on containers in production right away. But the idea was like we want to be the thought leaders in the container industry. So in 4.5 release last year, we put a lot of effort. In fact, our whole of QE, the test infrastructure, like the system testing. By the way, the guy who built this framework is Tommy. He's here. So he built this test framework, which is based on the container itself. So all our system testing, which pretty much all the system testing are run on the containers. So we do a lot of rigorous testing on the containers to make sure that when you run a database like Couchbase on a containers, it should be production ready, right? So in 4.5 we announced that we have Couchbase is a production ready, production certified for running on containers. So we have initially we saw some customers running a small workload or doing development testing on the containers. So now we have been seeing a lot of customers are getting confidence on running Couchbase on the containers. There are a few customers who are already running containers, Couchbase on containers in production right now. So this year, what has changed is like again last year it was all about containers. Now at that time there was no clear winner in terms of the orchestration technology. So there was Kubernetes, and each of the vendors like CoreOS had its own proprietary technology called Tectonics. Azure had its own Azure Container Service, and again the Mesosphere has its own proprietary open source one, the Mesos Marathon. So like there was many orchestration technologies. We wanted to, again at that time it was not clear which one we want to focus on. So this year it has been very clear now that Kubernetes has become kind of a standard. Pretty much like CoreOS abandoned their own Tectonics and switched to Kubernetes. Even Azure has adopted Kubernetes. AWS announced that they are going to support Kubernetes. So it's becoming very clear that Kubernetes is going to be the kind of a standard, and we should be focused on that. So from the product perspective, what we have decided is this year we kind of focused on adding a production support for the Kubernetes. So we have a development ongoing right now. So we are focused on building a native integration with Kubernetes. And again, the demo which Mike is going to show is just it's still in the development phase right now, but the idea is we will build a native integration with Kubernetes. So let me start a little bit talk about why Couchbase is the best fit for microservice. So we heard, as I said in the beginning, the microservices, the time to market is important. Agility is important. As I said, agility is one of the biggest reasons why microservices is becoming important. Easy scalability, right? So if you look at Couchbase, these are the things which we already do, right? So agility, we have a flexible data model. So the data model we support is JSON, which gives you flexibility. So if you guys attended the keynote, the demo after lunch, so what Ravi did was what Perry was doing is like he made a change to the JSON document. So we wanted to add the social information to the document. So they made a change to the JSON document and pushed the change, and that change also immediately reflected on the application. So let's say in the microservices, the idea of the same is like if I want to make a change, and if I say I want to bring a new service to the market, now the flexible of JSON documents, you can make those changes and push those changes, because end of the day your data has to support it, right? So and if your data supports a flexible data model, you can make those changes quickly and bring that application or that services to the market quickly, right? So elastic scalability, that's by nature. Couchbase itself is, again, Couchbase is a distributed data store, but one thing which is unique about Couchbase is like we have, we are a single node shared networking architecture, and I'll talk a little bit about how we scale each services in Couchbase. So the idea is like to get a linear scalability. So when I talked about microservices and having data closer to the microservices, you want to be able to add more scale your cluster, basically scale your data nodes along with your application. So in case of the Couchbase, because it's a single node and shared networking architecture, you can add more nodes that can easily scale your cluster. And then when you don't need them, you can elastically bring them back, right? So it gives you that ability to elastically scale and scale up and scale down, right? Again, data sovereignty per microservices, which is like the idea you can run a cluster of Couchbase, like let's say minimum of 3 nodes, a small cluster closer to your microservice itself, or it could be a single node, but because you need availability, you need data redundancy, you need a minimum of 3 nodes, right? So again, as I said, there is a new bucket type which we introduced in 5.0, which is the ephemeral bucket, which can be useful because it doesn't have persistence. Like you get a best performance plus it's an in-memory database, so you get the in-memory capability. But if you want to have a consistency, if you want to store the data, you can have a centralized database where you can push the data using XDCR. Sure, yeah. Yeah. Correct. No, the approach is, again, it's a recommendation, right? So if you want to have, again, as you said, it's like as part of the microservice itself, there's a close boundary of what you want to run with the services. So if you want to have a data closer, the good reason is like if you have data closer to your microservices, the performance will be much better, right? And again, as I said, if I want to make a change to my service and it relies on your data, so and if your database supports flexible data model and you can allow those changes, you can bring the changes much faster to your application, right? But end of the day, you want to have, let's say if you're building a big application, you want to have this data available for some other application. You want to replicate that back to the centralized database where you can share that data to the other application, right? So you can have the architecture where you can have microservices, you bring data closer to the services, but then replicate back to the system of record or for sharing to the other applications. Yeah. Yeah. So the ephemeral bucket is in-memory database, right? So it gives you awesome performance because it's like everything is in memory, but you want persistence. Again, it supports query, it supports full text search, all the capabilities we talked about in the morning, like the full-fledged data platform without persistence, right? So now you can use XDCR to replicate the data from the ephemeral bucket to the centralized database where you have persistence and everything else. Yeah. Cool. One other unique thing which we do, and again, this is why Couchbase is a good fit for containers, is like the whole idea of, again, we talked about in the keynote and a few other places we talked about this multi-dimensional scaling. The idea is like within the Couchbase itself, we have done something similar to what microservices has done, which is like focused on the workloads and separated them as a separate service itself. The idea is like, so every database will have the CRUD operations, it has query, it has indexing, and if you add search, so there is search indexes, so all of this will run on the database, on your database. So when we looked at it, when we were releasing query service back in 4.0 in 2015, when we had two new services two new things which were coming in the 4.0, which was query and indexing. So we saw the scalability for each of those workloads were different, right? For data, you need to scale them horizontally because it's like you can add more commodity hardwares and you can scale them horizontally. But for index and query, you need more horsepower. You need more compute. You cannot scale them horizontally. You need to scale them vertically, right? So by nature, the scaling factor for both of these workloads were different. So what we came up with, this kind of revolutionary technology, was like multi-dimension scaling. We separated this workload into separate services within the Couchbase. So we have a data service, we have query service, we have index service, we have search service. So, and it gives you a lot of flexibility. Let's say if I'm deploying on a cloud, on Azure, on AWS, so you can pick different instance type to deploy the Couchbase cluster. If I'm deploying on containers, the same thing. Like, the data service running on the containers can be memory optimized, which are good, has a good memory on the each machines in each containers. Whereas for the index and query and search, it needs more compute. So you can add you can add a container with more CPUs for the index, query, and search, and the full text search, right? So if you look at the whole cluster itself, it gives you a lot of flexibility in terms of, like, let's say my query service is running really. So let's say if I'm running a long-running queries and it is affecting my hogging my machine. It's not affecting your index. It's not affecting your data service. Likewise, if I'm running a lot of workload on my data service, it's not affecting your query and search service. So one other thing which is like we talked about developer preview of analytics service. So let's say if analytics service is another one which is running here, it can consume a lot of CPU. It can bring it's going to do parallel processing for your queries. That's not going to affect any of the other workloads, right? So it gives you a lot of complete isolation between this workload and the services. Again, if you look at from the container perspective as well as microservices, this fits really well into the picture. Let's say as I was talking about, so let's say if I bring my, let's say I have a data which is closer to my microservice, and I want to do a query, I can bring up a new node and run a query, just a query service on that node, and index on the another container. And if I don't really need them, I can even take them off without affecting your data at all, right? So you don't have to shard. Your data is, it's not getting sharded anything. So it gives you a lot of that flexibility. So I'll just quickly jump to the other one. So I'll talk about like what is microservices, how containers are powering microservices, and what we are again why Couchbase is a good fit or best fit for microservices and as well as containers. So here I'll talk about what we are doing with Kubernetes, right? So as I said, beginning of this year when Kubernetes announced the stateful sets, it was kind of dream come true because we needed the stateful sets for running the database on the containers. So as I said, like stateful sets has qualities of persistent storage, unique network identifier, graceful deployment and scaling, graceful deletion and termination, right? So these are all the needs. These are the characteristics which we need for database. We initially, when we started building this integration, we used this sidecar pattern, which was kind of considered as the good pattern to build the integration. The sidecar pattern is like there's a main instance, which is your Couchbase instance, and there's a sidecar container which is running next to your main instance, and it is helping the communication between the Kubernetes cluster and your main instance, right? So we built a developer preview based on that. In fact, that developer preview, I announced it in our blog. But what we have seen, again, as I said, Kubernetes itself is evolving very quickly. What we found out is there are a lot of limitations with the sidecar container. Because at the end of the day, the sidecar container itself is a container, so it can go down. So there are challenges with the sidecar container. So one thing which, again, we are working very closely with a lot of those, the Google guys as well as CoreOS guys, and we're looking at, we have an engineering team focused on the integration. What we found out recently is like building the integration using the Kubernetes operator is the best way to do it, because you can extend the replication controller itself. You can put a custom logic into the replication controller, in the controller itself. So the idea is like, so Couchbase cluster, Couchbase itself is a complex technology, right? So we have our own clustering technology, and we have specific, for example, I'll take an example of we are a database end of the day. So let's say if one of the node fails for some reason, it goes out of my cluster, and then after a few minutes, it comes back. So in case of Couchbase, what we recommend for this case is like we do a delta node recovery. Which the idea is like we don't want to, because it might have a lot of data on this node. It fails when it comes back. We don't want to resynchronize everything from the scratch. So in the delta node recovery, the idea is like it will find out how long this node was out and what is the amount of data I need to catch up, right? So it does the data node recovery. To implement this in the Kubernetes, it's going to be very challenging if we don't have that ability to extend the API itself. And that's why we decided to go with this Kubernetes operator. I'm going to invite Mike to just quickly show you again, this is in the development phase right now. So he's going to just quickly show you how a Couchbase cluster can be deployed on the Kubernetes and how we can scale them on the Kubernetes.
Okay, so I'm going to gloss over some details, but basically, so we extend the Kubernetes API. So basically, if you want to add in our custom Couchbase controller, all you have to do is run a single command that uploads a YAML file, which does two things. It tells Kubernetes about a Couchbase cluster type. And so what's nice about that is instead of using the current Kubernetes API, we actually allow you to just specify the things that are specific to Couchbase and leave out everything else. And I'll show you what that specification looks like in a minute. And the other thing that it does is it adds a custom controller. If you're unfamiliar with Kubernetes, basically if you have a stateful set, as Anil talked about, if you have a deployment, a service, all of these things are controllers. And so what we're doing is we're adding a Couchbase-specific controller to Kubernetes that's specifically for Couchbase. And the reason that you want to do this is because all the controllers that Kubernetes has, they're really good at creating pods. Stateful sets create pods of stateful resources. Deployments create pods without stateful resources. But what they don't do is allow you to put application-specific code in there. And so in the Couchbase instance, when you create your second node, just spinning it up doesn't add it to the cluster. You have to do an add node to a specific cluster, and then you have to rebalance the cluster. This takes care of all that. So you just run this one command, and that's it. Kubernetes now knows how to manage Couchbase clusters. And one other thing that I'm going to do, which is just for this presentation, is I'm going to actually start the controller myself. And the only reason I'm doing this is because I want to show you guys the logging output so you can kind of see what's going on. Okay, so I talked about registering a CRD. So basically, this is what an example specification would look like for Couchbase cluster. And so if you've used Kubernetes before, you'll notice kind is usually a place where you would specify deployment or stateful set or something else. You now just put Couchbase cluster, and that knows that this is a Couchbase cluster and that the controller that we registered is managing it. And so we're going to create a 3-node cluster. We're going to use 5.0. There's various configuration information on configuration for what different services get, what services there are, and then we're going to create a bucket. So if we want to do this, all we do is we run one other command, and Kubernetes will start creating our Couchbase cluster. And so if I look in the Kubernetes dashboard, I'll see, so I have the operator running, and then I have the first node that's starting to come up, and then it should take a minute to initialize. If I come back here to my logging output, we can see that it was trying to do the initialization, but the node hadn't come up yet. It's up now. We can see that it's starting to figure out what nodes are in the cluster and the various states that they're in. And then if I come back and I refresh again, you'll now see that there are 3 nodes. And then I'm going to open a port to one of the nodes so that we can actually see the cluster. and we can see that it's come up. And so I basically, what I did was I forwarded the port from inside Kubernetes to localhost 8091. And we can see the bucket is coming up. We can see that we have 3 nodes in the cluster and that they're rebalanced. So basically, with one command, you can create a whole cluster with any configuration that you need. And what's nice is you can version control all these things. And so if you want to give cluster configuration to somebody else, you just point them to a YAML file. They run one command. They load it up. So now what happens, let's say you're running this application. The performance is starting to be not quite so good. You need to add another node. Then all you need to do is come to this configuration. You change 3 to 4. And then you come back to your Kubernetes cluster. And you put replace. And so I'm going to replace this configuration. And then now you should be able to watch here. And we should be able to see 4th node coming in. Let's see here. Let's see what's going on. OK, so it's starting to initialize it right now. All right, so here it comes in. And now it's rebalancing. And so by just replacing the configuration with whatever changes that you want, our controller will automatically, it looks at the current cluster to see what the current state is. It looks at the new state, and then it tries to make them both match. So the things that we're working on right now, so obviously we have all this provisioning stuff. We're working on recovery too, but we plan on doing all kinds of other integrations for this in the future, getting XDCR to work, possibly adding backup and restore so that you can just add to your configuration. You'll automatically get backups, et cetera.
Cool. Awesome. Awesome demo. Thank you. Yep. Cool. So as I said, so we are building, it's in development phase right now. So we plan to do a beta as soon as we get something stable. But the idea is we are building this native integration build. Again, as Mike explained, when you add a new node, when you add a new pod, it should automatically join to the cluster and get rebalanced, right? So there's that. There's a monitoring. There's supportability, XDCR. There are a lot of these capabilities we have to build for this integration. All right, I had this much. I can get back to. Yeah. All right. And that's everything from my side. So if you have any questions, I can take now. Yeah.
So actually, the YAML file, you just said that you need 3 or 4, whatever number of nodes, right? Can you specify if that node is a query node or a index node?
Yeah. So that's planned for the first version. So this is an early beta. So right now, everything has to have the same running services. But one of the next things that Tommy and I are going to work on is making it so that you can say, I want to have 3 nodes with just the query service, or I want to have a node with query and index, and so on.
Yes, the MDS will be supported. Yeah, that will be one of the supported features. Yeah.
Yeah, but okay.
Oh, yeah. Yeah, and so the last question was whether we can support multidimensional scaling. So if you look at this configuration here, you have to, in this current thing, you have to have all the services the same across all the nodes. But one of the things for the beta release that we're working on will be to allow you to have multidimensional scaling. Yeah.
And is this file part of the release?
Yeah, so this file will be part of the release. So there's this, and then so there's another one. So when I ran the first command to actually install our controller, there's a file. So you'll get a file to do that, which you would never change, and then you'll get an example, some example files of clusters that you can create. Yeah.
Is this stored inside of the container, or is it?
So in this case, the data is stored on the specific node. So Kubernetes, so we don't have anything in here that shows it, but Kubernetes has various different ways that you can store data. So you can attach to network volumes. You can, if you're running in Amazon or Google, you could attach to EBS or various things.
Each container will have its own
Yeah,
It-
so
it
that's
can
one of the
attach-
options.
Yeah.
You can also have everything just locally, right? So for some people, they may say, like, I don't want to store everything on a network-attached drive. I want it to be really fast. I have SSDs on this machine. You can point it to store the data locally on those SSDs. So, per container, correct.
Okay.
Yeah.
Right. Thank you, guys.